Let's talk about mathematics. Mathematics is widely considered as the language of science which God has written the universe. Despite that it is the queen of science, the field of mathematics goes in an abstract direction. Let us think of the relationship in this way: we have a house. In order to live here for a long time, at some point, we must have some housekeeping work done. This is the relationship between mathematics and science. We have the science as the house, but the house could not work well without housekeeping, which is where mathematics comes in. In the meantime, housekeeping alone does not make sense at all unless we have a house. The nature of mathematics indirectly explains the world gives itself an embarrassing situation. It has extensive real-life applications, but we do not physically see the real-life applications. Mathematics usually comes in a separate, compulsory subject in schools. As our education progresses, mathematics comes in a way that is more and more abstract. More and more alphabets and less numbers. Until it reaches a point where you ask yourself, why am I sitting here doing something meaninglessly? Surely I can provide you a variety of real-life examples on mathematics, but instead, I would like to direct you back to a major word that we all missed in the beginning. Language. The thing is, mathematics is often linked to science, and thence when we interpret this quote, our emphasis was put on the importance of mathematics in the meaning of science. In this video, I shall be attempting to reposition mathematics as a language. Hopefully you would find mathematics is useful by the end of the video. But before this, I would like to make a disclaimer. Mathematics cannot be learnt overnight or just by watching my videos. As with learning other languages, it needs to be done over time by reading and practicing over and over again. This video only aims to put your mindset in a place that is optimal for your brain to absorb mathematical knowledge. If you would like to watch more on this kind of content, click on the subscribe button below so that you do not miss out any future videos. First thing first, we need to make sure that what we actually mean by a language. In the simplest meaning, language is a system of communication used by people living in a particular country. We can easily find an analog of mathematics in science. It is the bridge where scientists communicate and express ideas. Mathematics starts from counting, where numbers were developed. But this was very niche, there were nothing more to show other than the quantity itself. In fact, in early mathematical publications, theorems were written as plain language in Greek. It was not long that the language barrier made the development of this field difficult. At the same time, scientists found that the vocabulary of mathematics is not enough to convey the amount of information they want to share. Therefore, as the time passes, mathematicians develop more and more symbols to describe the situation efficiently. This is reflected in the curriculum. Since we are now talking in English, let us compare mathematics with English. In junior school, we learn English vocabularies, then as the time passes, grammar and sentence structures came into practice. The goal is to train students to be able to communicate with English, both verbally or in writing. The same thing is going on with mathematics. We started with counting numbers and basic arithmetic. Then as we progress, we start to learn algebra and how to do deductions using mathematical expressions. The idea is to train students to be able to communicate in mathematical language. Communications in mathematics are largely done in writing. This includes expressing relationships between quantities, analysis using mathematical tools as well as proof writing. So the first thing that we need to do is adjust our mind that mathematics is a language. It happens naturally when we want to communicate. Whenever you learn a theorem or definition, you are strengthening your own dictionary of mathematics, so that you can communicate effectively and comfortably in all scenarios. However, if we start off learning mathematics as a science, thinking of how it is being applied in real life, we would easily get into a loophole. There is no use to learn this knowledge, so I am demotivated. I just learn what am I supposed to know. It would then appear as a bunch of abstract symbols, which are absolutely useless in real life. The best advice for not falling into a loophole is to avoid it at the first instance. Just as we learn and remember new English vocabulary without a specific reason, we study mathematics without the need of asking when does it apply to real world. Now we made clear that nowadays mathematics is an adequate language for scientists to communicate and explain ideas to the world. From Newton's second law to Einstein's most famous equation. But is this where language ends? We do not only learn how to use English in school. We also learn literature, so why? Nearly all languages on Earth is associated with a culture. A language and a culture have a complex and homologous relationship. Usually they evolve together, influencing one and each other. To take a deep look at this, let us consider the English language, since we are already using it. If we are to consider each English evolution phrase, we can see that each phrase was associated to a mnemonic change. Moreover, one can also see a major change in style in literature. So let us get back to mathematics. If we are to treat mathematics as a language, we must also investigate the culture of mathematics. By culture we means the arts and other manifestations of human intellectuals' achievement regarding collectivity. Literatures from different periods reveal the difference in belief and thinking in the past. Studying this kind of history is a way to visualize the timeline of how modern civilization was developed. By studying literatures from ancient mathematicians, we can see how modern mathematical theories were developed. Mathematicians did not propose a theory in vacuum. They were influenced by the thoughts and belief at that time, as well as the problems that they faced. It is a collaboration of the scientific and even political society where they were in. If we are to put a timeline to the history of mathematics, we can roughly visualize it in this way. Ancient mathematicians start off with geometry and numbers. They treat numbers as an extension to shapes and measures. There is no doubt that the notion of pi came in so early on the timeline. Slowly the study had become emphasizing on numbers. In the 17th century, scientists found a relationship between numbers and nature. So a lot of modern branches started to be developed in this time period, including astronomy, probability and mechanics. Starting from 18th century, mathematicians started to correlate different branches together, and develop mathematics as a separate subject than science and nature. Quite often, a mathematical theory was developed to solve an outstanding problem at that time, but the impact of such theory did not end just by solving the problem. It then extends to an extensive applications. For example, the most famous work of Einstein, general relativity. It uses concepts of differential geometry. This was not invented by Einstein. In fact, it was developed by various mathematicians in the 19th century attempting to finalize Newton's work in calculus. But it turns out that it is an extremely useful tool on explaining relativity. Studying literature and history develops our critical thinking skills to think about a topic from different perspectives. It inspires our imaginations by broadening our horizons. Writing techniques from poets in the past are still useful in modern day-to-day conversations. Modern study in mathematics treat mathematics as a standalone subject. Studying works from the past and relating various theories from different branches, mathematicians connect and construct more advanced and improved topic. Rather than treating it as a tool to explain the world, modern mathematical thesis looks more like an art piece, self-explaining the beauty of mathematics. Mathematics is a traditional, well-established subject. This means that mathematics has its own long-lasting history, as well as its own literature and culture. So my piece of advice that I would like to give you, when you think that mathematics is meaningless, helpless and useless, you might try to reposition it as a language. Try to experience and explore the significance instead of asking for answers. Just as you can feel the romance yet helpless by reading the tragedy of Romeo and Juliet, you can also feel the elegance and desperate by studying real analysis. In fact, I made this video as an introduction to the upcoming series of videos on the language and literature of mathematics. I have left a lot of gaps in this video that I would like to fill in the future. So if you like this kind of content, consider subscribing to the channel so that you do not miss out any further video on treating mathematics as a language series. I will see you next time.